Hey guys, welcome back to my channel, and today we will be continuing the more advanced parts of matrices. So first we're going to find the determinant of a 2 by 2 matrix. So let's say we are given a matrix A equal A, B, C, and D. So we usually denote determinant by the A between two lines, and these lines we call the modulus. So we're going to write, and how we find the determinant is we say the leading diagonal. So the leading diagonal is this way. So it is A times D minus this diagonal here, which is B times C. Now, if A is equal to, and this is equal to 0, then A is said to be a singular matrix. If the determinant is not equal to 0, then it is considered a non-singular matrix. So if you have this, so let's try an example. So let's say we have A is equal to 3, 2, 1, 4. And we want to find the determinant of this matrix. All we need to do is say the leading diagonal, which is 3 times 4, minus this diagonal, which is 2 times 1. So 3 times 4 is 12, and 2 times 1 is 2. That means the determinant of this matrix is 10, which means it is non-singular because it is not 0. Okay, so let's say we have A is equal to A, B, C, D. How we find the adjoint? All we need to do is for the leading diagonal, we switch positions. So the D goes where the A was, and the A goes where the D was. And for this diagonal here, if it was negative, it becomes positive. If it was positive, we change the sign. So this now becomes a minus B, this becomes a minus C. Let's try an example. We had A is equal to 7, 1, 3, 5, and we wanted to find the adjoint. So first things first, we switch the positions here. So this is 5, this is 7, and we change the signs of this diagonal here. So this becomes minus 3, and this becomes minus 1, and that's it. Let's say now we wanted to find the inverse of a non-singular, and remember non-singular, the determinant is not equal to 0. Non-singular matrix. So let's say we have A is equal to A, B, C, D again, and we want to find the inverse. So the inverse is denoted by A to the minus 1. And all we're going to say is A, B, C, D to the minus 1. So there's a formula that we use for this. It is A inverse 1 is equal to 1 over the determinant of A times the adjoint of A. Say we have A is equal to 2, 1, 3, 5. The first thing we need to do is find the determinant. And that we do by saying the leading diagonal, 2 times 5, minus this diagonal here, which is 3 times 1. So 2 5 10, minus 3, so the determinant is 7. What we need to do now is find the adjoint. So the adjoint of A is equal to, we flip the first the leading diagonal and we change the signs for the other. So all we need to do now is say A inverse is equal to 1 over the determinant times A's adjoint. So now all we need to do is just fill in for what we know. So A inverse is equal to 1 over 7 times 5 minus 1 minus 3, 2. And we can basically multiply, if you remember from the previous video, we did scalar multiplication. This here can be multiplied by each term on the inside of the bracket. So we could simplify this and say 5 over 7 minus 1 over 7 minus 3 over 7, 2 over 7. Here we don't usually need to do this. We could have stopped here. Interesting to always keep in mind is if you have a matrix A and you multiply that by its inverse, you're always going to get the identity matrix. And the identity matrix is equal to this here. As you can see, the leading diagonal has 1s and the opposite diagonal has 0s. So that's just something you need to keep in mind. So let's try and solve simultaneous equations using matrices. Let's say we're given a pair of simultaneous equations, 4x minus 5y is equal to minus 6 and 3x plus 2y is equal to 7. The first thing you'd want to do is the numbers beside the variables, you put them in a bracket by themselves. So the 4, the 3, the minus 5, and the 2. You put those in a bracket by themselves. Then the variables you put in a bracket by themselves as well. Then the numbers on the right side of the equation, or the numbers by themselves, the constants, you put them in a bracket by themselves. Now that they are in this form, it is easier to solve. So it is in the form AX equal B. So what you need to do is multiply both sides by A inverse. So you get A inverse times A times X is equal to A inverse times B. What you'd know, A inverse times A is equal to the identity. So it's the identity times X is equal to A inverse times B. Now the identity times anything gives you itself. So that means this is X is equal to A inverse B. So this is the final form that you want because you're finding for X, which are the X and the Y here. So since A was given to us as 4, 3, minus 5, 2, that means we can find what A inverse is. So A inverse is equal to 1 over this times the adjoint A. So the determinant is leading diagonal 4 2's 8 minus 15 times the adjoint of A, which is we switch the leading diagonal and we change the signs and for these here. So if we were to simplify this, we would be saying (1 over 23) 2, 5 minus 3, 4. So this is A inverse. Now remember the formula is X is equal to A inverse times B. We know that X is this. We now know what A inverse is, which is 1 over 23, 2 minus 3, 5, 4. And we know what B was, which was minus 6 and 7. So all we need to do is multiply these and expand and simplify, and we get what x and y are. So let's go. So we leave the 1 over 23 here, and first we need to know if these are compatible to multiply. So we have a 2 by 2 and a 2 by 1. So of course they are compatible, and you'll get a 2 by 1 matrix. So it is 2 times minus 6 plus 5 times 7 minus 3 times minus 6 plus 4 times 7. Get 1 over 23. We have minus 12, 18, 35 plus 28, 20. So we have 1 over 23, and we have 23, and we have 46. So now remember, this is a scalar, so it can be multiplied by each term in the bracket. So 1 over 23 times 23, so we have xy, is equal to 1, and 46 times 1 over 23 is 2. That means x is equal to 1 and y is equal to 2. Let's say a question said to you, M is a singular matrix. And it gives you k, 5, 4, minus 2, and it asks you to determine k. The first thing you know about singular matrix is that the determinant is equal to 0. So all you need to do is find the determinant of this, which is minus 2k minus 4, 5, 20. And all you need to do now is just equate it to 0. So it is positive 20 equal to minus 2k. And if you divide both sides by minus 2, that means k is equal to negative 10. And that's basically all there is to matrices. Thank you guys for watching, and see you guys next time.